Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Alex Ellis. He's the founder of the OpenFaas project and a Docker captain, and I'm a big fan of his blog at alexellis.io. How are you, sir?
I'm good. Thanks for having me, Scott.
Yeah. I started at your blog, which has grown into just a huge resource for technical articles and tutorials on Docker and Linux and Raspberry Pi and all kinds of stuff. I found you originally on Hacker News a long, long time ago. And just every week there's something great on your blog. And then I saw that you had built a wonderful project, which was a big Raspberry Pi cluster that ran Kubernetes. And I knew that I needed to do that as well. Can you just maybe back me up and tell me how you got that idea and why are people building these things on Raspberry Pi?
Yeah, so I actually started a technical blog about 2.5 years ago, and I think I easily hit 100 or a few hundred posts already, and there's at least 80 on Docker. Most of the Docker ones are about containers and the Raspberry Pi combined. Now, it just seems like the Raspberry Pi is really aimed at all people. It really brings people together. So kids will use it to learn how to code or to play games, and then adults at home will just get absolutely fascinated by this ability to control hardware or to build a cluster. And, I was no different. And after initially playing with it and thinking, well, I can't really use this as a desktop, I started looking at what else could I do, which involved controlling hardware and building clusters.
Mm-hmm. Yeah, I had been thinking about Kubernetes for a long, long time. And I thought to myself, I'll do this online. I'll do it at Google Cloud. I'll do it at Azure. I'll do it at whatever. And somehow it didn't capture my imagination. But sitting here talking to you and looking at my 6 Raspberry Pi cluster running on the metal, I felt like I learned more about Kubernetes. It wasn't this abstract thing that ran in the cloud somewhere that I couldn't see. It was real, and building it using your instructions just made it more fun and more physical to me.
Yeah, I think that's definitely one of the things people absolutely love is that satisfaction of being able to watch the blinking lights, seeing all of those packets going backwards and forwards, and having something that's just real and tangible. Now, I remember one of my colleagues, when I told him I was going to buy an Intel NUC and have it at home as a home lab, and he said, well, why waste £400, $600 when you can just run a VM on your laptop? And, I knew that he was kind of one of the guys who just didn't get it. And I've had just as much satisfaction of running, a small low-powered server 24/7 as I have with my Raspberry Pis. And, my house is absolutely full of them. Occasionally I have to just shut a whole load of them down so I can stop worrying about the IP address conflicts.
That's fantastic. After I built mine from your instructions, and then I wrote up instructions on how I bumped into things, I did notice that a lot of things change. I've had people say that they've read my blog, read your blog, and then they found that a version had changed or that instructions worked and then they don't work anymore. Why is that? Is the community moving faster than our blogs can write it down?
So there's 2 main ways of doing clustering. You've hit on the Kubernetes, which is probably from about midway this year onwards is what I've been writing about. But before that, I was writing very much about Docker Swarm. Now, there was the old incarnation of that, and the more modern one launched about a year ago. Now, I find that generally the Docker Swarm doesn't break. The instructions for installing Docker are pretty much a one-line install. They're kind of static. However, even with a regular Kubernetes installation, I did Kubernetes in 10 minutes on bare metal. I find every other week it's completely broken and I've not changed anything. And it will be because we've gone from 1.6 to 1.7 or 1.7 to 1.8. And it may be that the networking driver you were using is now on a different URL to where it was, and they've broken their redirect. And you're right, it just seems like keeping up with Kubernetes is a very time-consuming exercise, and folks like us who are trying to condense it down and provide solutions for other folks to get up to speed quickly is really hard. So I think one of the things that we do is we condense down the concepts as well as the individual steps. And so it helps when people come and they say, well, actually it all works apart from that one networking link didn't work. I'll Google it, and they can pretty much get going again. But it is a shame. And I kind of wish that there was a little bit more cohesion with that.
Yeah, I used the example of many, many, many years ago, 1986, 1987. There was a version of GIF that came out, was GIF 87, and then GIF 89 came out, and then GIF 89A. And it was a time where everyone's like, can we just pick a format and not break it? And that sounds silly because now we take all of those things for granted. The same thing happened with MP2s and MP4s and videos and compression. It seems like we're trying to figure out what the best solutions are for all of these things. And maybe in the future, we'll be able to do a one-liner that sets up a swarm or sets up a cluster. But today, maybe it doesn't feel like it's ready.
Yeah, I mean,
but people run the stuff in production.
Look, you can do it. You just have to be aware that the ecosystem is changing, and much of Kubernetes is still in an alpha or beta state, which means it's not ready for production. The concept of a deployment, which is how you say, this is my app, this is how many replicas I want, you please do the magic, only just became stable, generally available. And yet that's something people have been using in production for quite some time.
Yeah. So on top of all of this, after I built my Hello World, I use .NET, and I know that you've transitioned to Go. There's Python examples. I went and I did basically put up a Hello World.NET website. But then on top of that, there's OpenFaas, the idea of a serverless infrastructure. Maybe you could juxtapose the kind of the interest and the irony of a serverless infrastructure where you don't think about the servers and how fun it is to build a project like a Raspberry Pi cluster where all you think about is the servers in the middle.
Yeah. So when I go and I speak about serverless and OpenFaas, what I really start to try to do is explain what we have is a new architectural pattern under our belt, which is serverless functions. Functions are small, reusable, discrete pieces of code that you deploy once and pretty much forget about. The system manages it for you. Now, when you pick OpenFaas, what happens is you actually get a handler that you write and define. You say what dependencies you want, and everything else is kind of like magic for you. You don't have to learn Docker in great detail. You don't have to learn Kubernetes in great detail. In fact, you can swap out Kubernetes for Nomad from HashiCorp or even Docker Swarm, and everything will pretty much work exactly the same. And so really, we're looking at a pattern that is just as disruptive as microservices were. In fact, it's almost like a nano services. These pieces of code really help you focus on the task at hand rather than managing everything yourself. That's really what we're focusing on. So we'll include batteries, included ways of doing stuff. And that's why it's kind of closer to that serverless model.
That's a great point. I remember many years ago when we used to build web farms, we'd go and buy load balancers as dedicated devices, and that the idea of making a load balancer and making a web farm was like a foreign language. It was an amazing miracle, and you needed to go and hire a company and a consultant to do it. And then it became a checkbox and a slider bar somewhere in the cloud. And now with things like, Zeitz now, you just press enter and the web farm is implied. With serverless, it's just hidden from you entirely. You don't even think about it. You just write functionality.
That's right. And I think when you get to that experience, you've kind of hit serverless on the head. That's exactly where we want to be. Now, whether your ops guys have actually provisioned a cluster that you don't see, or whether a cloud provider has provisioned a cluster that you don't see and don't understand the binning of, it's kind of the same thing.
I thought it was interesting when I was learning about OpenFaas, and again, this is Open FAAS, that people can go on Google for. And when I was learning about this and trying it out, the first thing I was struck by was that I wasn't talking HTTP, I was doing console output. And I was like, that's weird. Like, I'm doing a website, I'm doing a web function, I should talk to HTTP somehow. But it didn't prevent me from really doing anything. Talk to me about that architectural decision and why that's interesting.
So the thing about HTTP is that it's a daemon for running long-running processes, and it's a text protocol. Really, when you come to OpenFaas, you're effectively writing, to most intents and purposes, a console application or a handler that belongs in a console application. And it goes back even further in time to CGI and fast CGI, which were two technologies that came out around the 90s. And they were how the web originally scaled. Now, they kind of lost out to HTTP and these long-running daemons, like Apache. And so you'll still see some parts of CGI in modern applications, but they'll tend to run these highly optimized servers instead. Now, that means that we're just kind of used to that, just like we are with smartphones now. Like we wouldn't know how to go back. However, there are several things that make it really well suited to a serverless architecture, particularly that concept of a short running task that has an input and an output.
Okay. And when you are shelling out to these processes, are you making new ones? Are you reusing things? Is there pooling? Are you talking over a socket or a pipe?
So there's actually two main modes. The first one is basically compatible with anything under the sun. And that will be the forking mode. So you can look up a serverless guide for how to resize an image, and everyone will tell you, you need the node template, you need to install this library that needs native compilation, and you end up with this massive Docker image and this Node.js code, and all it does is just calls a module and says, resize my photo. Well, actually, with OpenFaas, you can make image magic the actual binary that runs as your function. And the reason we can do that is because of this forking mode. Now, that's great. And so you can take your C++ binary or VB6 code from 25 years ago, and you can run it as a function if that makes sense for your business. And then some of the time, people actually say, well, look, I need really high throughput. This thing needs to absolutely get hammered from every angle. Let's make it more efficient. In that instance, you can pick up what I've coined afterburn, which is much more similar to fast CGI, where we'll create a process or a pool of processes and reuse them over and over again to do that, to run that piece of code for you.
Oh, okay. So this, like you say, it's not a new technique, but it's a smarter technique in that function watchdog that is part of OpenFaas keeps that, forks the process and then keeps it around for other requests. So then if you take something with a slow startup time, like .NET Core or Python, this speeds it up dramatically, like many X?
Yeah, like at least 10X, probably more. And it isn't, those languages are actually really fast. The ones that are kind of a bit slower are Node.js and particularly Java. I mean, the JVM is designed to be started and run for like 40 weeks. It's not designed to run for 4 milliseconds. So there's some really good use cases for what we're calling afterburn.
Wow. Okay. And this is all kind of included in and within the OpenFaas project. This is a feature of OpenFaas.
Yeah, it's all within the wider ecosystem.
Another thing that I thought was really fun that you all did, and it looked like it was a Colorize bot. Who did that? Yeah.
So Colorize bot is quite a long story, but to cut it short, I got, and this was actually through clustering as well, got in touch with a young guy in the UK called Finian. He was 17 at the time, and he'd built a Raspberry Pi cluster, about 7 nodes, and blogged about it using my tutorial. I thought, well, this is really great. I'd love to get in touch with him and pay forward some of what I've received from the community and from Docker as a captain. And so I got him connected to Docker, and we managed to get his trip sponsored out to Austin, and he spoke there, and we kind of kept that relationship going. And Copenhagen came around for DockerCon, and so he had thought, right, I want to use Alex's OpenFaas with my friend Ollie, and we want to come up with something that, uses machine learning. And their idea was to take a black and white video and turn it to color. As they did that, they went through all these different mechanisms and ways of doing convergent neural networks, but they found it just way too hard, and they didn't have compute power. So they took something off the shelf called Kafka I believe it was from MIT, and that will take any black and white photo and restore it to color. Then off the back of the conference, we sat down and architected ColorizeBot. Now, this is an OpenFaas project, and it has some long-running stuff because not everything needs to be serverless, and it also has some functions. The main function there is one that goes from black and white to color using binary bytes, and the other one tweets a photo. Now, it's been shared all around the world. It's had a lot of interest from all sorts of people like Doctor Who fans and folks who have their family photos. And it's really a great story of collaboration and working together in a community.
One of the things I think is so interesting about that story is that Finian and Ollie were 17 at the time. And, we talked a little bit in this podcast about age, and you referenced things in the 90s and I referenced things in the 90s. And that means possibly that the next generation of developer will be able to consciously or not choose not to worry about stuff that we worried about. They made a big global scale application that did cool stuff. And what kind of stuff did they not have to worry about that you and I would have 10 or 20 years ago?
Yeah, I mean, that's a great theoretical question. But there are, a few practical things I can say. They didn't have to worry about installing a LAMP stack. They didn't have to worry about tuning a web server. They basically had a Docker Swarm cluster, and when they said create this service, everything was just done for them. When they said, get me the logs for that service, because it's a distributed system, they would just fetch from whichever server they were running on and brought up on the console. Some of the things they had to worry about, and where I particularly helped them, was the architecture, the durability, thinking about error handling. And there's this great photo of the three of us sat up in the hotel lobby late at night looking at their slides, and we were adding error handling. So if we couldn't tweet, the whole thing didn't just fall over in a heap. And I think it's great to be able to focus on those high level discussions and pieces of code without worrying so much about the real low level. How do we keep this daemon alive? How do we do this and the other?
And how much time was put into this from kind of concept to success?
It was a multi-week project, and it has not stopped needing our time since then. In fact, it's been ported over to Kubernetes now, and is running on Google Kubernetes engine. And that was actually part of the keynote from Alexis Richardson at Weaveworks during KubeCon. And it was just so great to see OpenFaas up there and the story of what we'd done. And his kind of angle there was, could you have what I think it was 10 million developers on Kubernetes in the next few years? And what was really great was the more you build with components, the easier it is to iterate and to get the traction.
Do you think that Kubernetes at some point will become like a part of the fabric of the internet itself, and it'll just become a thing that fades away in the background? Or, in the sense of it'll become a part of the operating system of the internet itself? Or do you think that there'll always be competition for swarms and cluster managers and orchestrators? Well,
competition is always useful, always helpful, right? We've seen that with sort of getting a bit closer to home with web browsers.
Indeed.
Right. And so I think the way the web browser is so integrated into operating systems now was controversial originally, wasn't it?
Indeed.
But now we just take it for granted. Touchscreens were controversial, and now we couldn't work without them. And I think in the same way, Docker is becoming a tool that you just expect to be installed or installable on a Linux system or Windows or Mac. I think we will get there with orchestrators. They are very large, complex pieces of application. And just like we said at the beginning of the podcast, they're changing the whole time and they're breaking the whole time. I want to get to the point where we get to this boring components that just work and aren't changing and easily extensible.
Well, let me then push a little bit on something that you said before in an effort to better understand. You said that the Colorize bot took a couple of weeks, and it also sometimes still requires your attention. What kinds of things do require your attention? Why aren't we at the point where I can just have a slider bar and a credit card attached to it? And, it scales. I need to move the slider bar to the right and pay more money. What kind of administrivia are you spending your time on?
When you look at Colorize bot in particular, like, no, I don't have this. I don't have this on record, but my impression is that Twitter don't want you to run bots. It kind of will cause them problems. That's my impression. Right. And so every few days or few weeks, we'll find that the bot is triggering some kind of spam alert or filter, and we have to regenerate the keys for that by getting Finian, who holds the account, to log in New Zealand. He has to message me over Slack. I have to find 30 minutes to log into the GKE cluster, update all of the YAML files and redeploy it. And so to some extent, it's just an artifact of, we're relying on a third party here. But really, there's nothing that we're needing to change in the code. The functions are self-contained, they're immutable. And then we actually use for storage, we're using Minio, which is a kind of an S3 alternative you can host yourself. So when a tweet is picked up from the internet using this long-running service, Tweet Listener, it will store the photo in Minio, invoke the function on the gateway asynchronously. So asynchronous queuing is built into OpenFaas. And then that event will trigger the colorize and the tweet of the pick. We also have dashboards that we have developed using the metrics that are built in. So we can use something like Grafana, have a very pretty dashboard, see what the statistics are, but also what the rerun or the failure rate is. And that's a clue that we need to go off and do something.
Okay. So the problems of scale are less of an issue, and the problems of the external dependencies are what your kind of administration is. So that's comforting.
Yeah. So when you're pushing the boundaries and you're getting more and more third parties involved, this is just generally the kind of stuff you end up having to deal with. Also, moving to Kubernetes was not as easy as we'd hoped, because while OpenFaas moves really fast, really quickly, we had other services, like we had Minio, we had this tweet listener, which was a long-running process. They needed their own kind of configuration, their own specific YAML files. And then there were things specific to GKE that were like, how do we pick an instance that's as fast as the one that we've been using on another cloud provider? And so, it's great to see this, because I think this is what people are going to be going through when they actually are saying, right, well, we're running OpenFaas in production, we're using it for business. How do we go from GKE to Azure, or vice versa, or to bare metal? What are the pros and cons?
Right. I think the fact that you brought up Minio, MINIO, .io, is a really interesting point, because I think that Minio has a similar philosophy to OpenFaas, in the sense of it's an open source thing that has a clean API, but it works across all major clouds. So just to give a little context, Minio gives you an Amazon S3 compatible API, even if your storage is in Amazon. It might be Azure, it might be Cloud Foundry, it might be Docker or NAS. OpenFaas also works anywhere. I can run it anywhere that I want to. It doesn't have to run on Amazon or have to run on Azure. I assume that's why you picked Minio, or they would pick it, and then you would probably prefer projects that are cloud agnostic.
So, funny story. I had I was looking at the DockerCon Cool Hacks contest, and that's kind of why I started part of why I started OpenFaas. And I was doing everything I could to make OpenFaas, just as simple as possible. I now have this tagline, serverless functions made simple. And there was this remit, push Docker beyond what it was designed to do. And for weeks at a time, I was really struggling to convince the panel and committee about the project. And eventually it kind of clicked for them. And so I went over to Austin and was able to present that in a closing keynote in front of 5,000 people. But one of the changes that I made to the wider open source community was to commit webhook support to Minio because it didn't have it. And I knew for OpenFaas, to keep things simple, the simplest communication mechanism for the web, the lingua franca, is the webhook. Webhook is where you say to GitHub, for instance, anytime X happens, send a HTTP post to this URL. And so that's another reason why I went with Minio at the time, because I knew it. I knew the team. They were great people. And I was able to contribute the changes I needed that now all the other serverless projects are using in their demos, the change I added to trigger their functions.
Interesting. Okay. So it's right in line with your philosophy and would allow me to run my own colorized bot at whatever cloud or whatever infrastructure that it made me happy.
Yeah. I mean, look, there's something that I want to say really is that OpenFaas is a project that I started last December. So we're probably 12 months from my first commit now. But that journey has been a long and hard journey. And actually, a lot of people have come along the way. We now have around 69 external code contributions, or contributors, let's say, 1,500 commits, almost 8.8 thousand GitHub stars, and actually have this goal of getting to 10K by the end of the year. We might have to push that out a couple of months. But each kind of milestone of X thousand stars has been tied to something really significant for the project. But the one thing that I think has really been a catalyst and is really important to me is the community and how much of a investor in people I've become by seeing people come to the project and being able to spend time mentoring them or teaching them Go or just promoting them and being kind of altruistic and seeing them collaborate together is so rewarding for me.
Yeah, and that really is the point, right? Is to lift everyone up and have, a rising tide lifts all boats. And in this context, people will probably start building things on top of OpenFaas, and that will lift them up.
Yeah, so that's something that I've seen because it's an open source project. There, and you'll see this in the new year. There's several big brands that have taken it and built cool stuff with it on top. And there are also people that are taking it to production and building their cool stuff with it too. So this is definitely an ecosystem that's really picking up. And there was a tweet from the New Stack, and it basically showed from a survey that in the open source world, OpenFaas was tied with OpenWhisk for second place for mindshare. People using or planning to use serverless and open source next year.
That's cool. And this is all in a year, which shows you how fast the open source community and the internet goes when they find something cool and they move.
Yeah, absolutely.
Yeah. So people can check out OpenFaas at openfaas.com. And from there, you can go to GitHub. And I would encourage you, if you're listening to this podcast, to go and star it. Give them your star and see if we can push them to 10,000 by the end of the year. I'll try to give you my small contribution. If I could unstar it and star it again, I would do that.
Well, look, there are multiple repos across the organization because OpenFaas isn't a single repo project anymore. There's all sorts of components that are really important, and people contribute to different areas, which just reflects like the interest level that we have here.
And that brings up a good point, because it's not just a project sitting in one place. There's the CLI, there's the Fastnetis stuff, there's the Fast Swarm. When you start to make something like this and remembering that you're not paid to do this, right? This is an open source project
Yep.
that you poured your soul into, and there's lots of people that are involved, but it's got a nice brand. It's got a great logo. It's very professional. The docs are fantastic. Your blog is a great resource. I spend a lot of time there. But if you go and look at, like, you have a Patreon, you're not getting rich on this. How do people get involved and help you out and help the community out with this project?
Yeah, so it's incredibly time consuming to run a project. It's even more time consuming when you're trying to lead a team of contributors from all over the world. Most of my time isn't coding; it's actually just supporting people and coordinating. So if you want to get involved, I'd encourage you to just start using it. It takes 60 seconds to get up and running on your laptop with Docker. You don't even have to learn Kubernetes if you don't want to. You can join our Slack channel by emailing alex@openfaas.com or hit me up on Twitter. And then one of the other key ways, like Scott said, is you could just become a backer of the project on Patreon. And there's also opportunities to become a sponsor if that makes sense to you.
Fantastic. Well, thanks so much for spending time with me today, and I wish you all the best with the future of OpenFaas and serverless functions made simple.
Thank you. It's been great to talk to you.
This has been another episode of Hansel Minutes, and we'll see you again next week.